Good morning, everyone. Till now, we have seen what is meant by PCB and what are the components of PCB and advantages of PCB, then different types of PCB and manufacturing of different PCB boards. That is a single-sided PCB, double-sided PCB, multi-layer and flexible boards. Today, we will see an overview of PCB design process. That is, before going to see the PCB design process, first we will see few key points to be known for designing a PCB. So everyone open the slide. In slide number 2, there are first we will see what is meant by part and how we are going to specify the part and what are the packages, pin names, part list, net list and making net list files and so on. So in this process, today we will see few of them. So go to slide number 3. In slide number 3, the left hand side, you can see an image showing the schematic diagram of a stable multivibrator. I hope you all know a stable multivibrator. It is used for generating continuous pulses. A stable multivibrator is a simple oscillator. It is used for generating continuous pulses. Here, a stable multivibrator is constructed using any 555 timer. Here a 555 timer IC is used. Okay, so we'll see what do you mean by parts. So parts means the active and passive components is available in the design. So active means resistors, diodes and transistors, active components. Then passive components means resistors, inductors and capacitors. So if we see in the schematic diagram available in the left hand side of slide number 3. So what are the components available means there's a IC, any 555 timer IC, then resistors, there's so many resistors, capacitors and LEDs. So all these are parts. So the IC, resistor, capacitors and LED all are known as parts. That is, they are the essential elements which are required to design the circuit. Here we have considered a stable multivibrator. So for constructing a stable multivibrator, what are the essential elements we need? That is known as parts. Go to slide number 4. In slide number 4, all those parts are represented in terms of symbols. In the first, we are having resistor symbol, next capacitor, then diode, and then an IC, that is LM317. LM317 is a positive voltage regulator IC. It is a 3-pin IC. Here, for each and every parts, we are having pin number. See, for resistor, we are having 2 pins. It is represented by pin number 1 and 2. For capacitor also 2 pins. Diode also 2 pins. Then for IC, this is a 3-pin IC. So it is marked as 1, 2, 3. So each pin has its own unique pin number assigned to it. Then all those parts is component body. So component body means each symbol has a graphic or drawing representing the parts. For example, if you see the resistor means that symbol, the drawing represents it as a resistor. That is the component body. So in the capacitor also, the straight line and the curved line represents the capacitor body, then diode, then an IC. So all those has a component body. Next, each component has its own unique name. That is, each symbol, resistor, capacitor, diode and IC will have its own name. For example, if you are going for a PCB designing tool, in PSpice itself, you might have seen while choosing the components, the resistor will be given in some name and the capacitor will be given in some name. With that name only you will be choosing that component and you will be placing it in the schematic diagram. Likewise, all those components will have its own unique name. Here the name given is RES for resistor, CAP for capacitor and diode, and LM317 for that IC specified here. And each component has its own reference designator. Reference designator means if you see the circuit diagram, that is a schematic diagram provided in the slide 3, there are several resistors R1, R2, R3, R3. So all these all resistors are named by a reference designator, that is R1, R2, R3. The capacitor, we are having two capacitor that is named by reference designator C1, C2. So each symbol has a reference designator assigned to it that uniquely identifies the symbol. That is, we are having so many resistance and two capacitance. To uniquely identify that capacitor, we are providing the name to that capacitor, and that is known as reference designator, the C1 or C2. Likewise, if we have more number of diodes, we can have D1, D2 like that. That is reference designator. Okay, next we'll see the symbol properties. So what do you mean by the symbol? Symbol means in the slide number 4, the symbol for resistor, capacitor, diode and ICs are provided. So that drawing provided is known as symbol. And what are the properties incorporated with the symbol? We will see. So in 5th slide, the symbol properties are mentioned. There is a part number, component name, reference designator, package name, value, manufacturer and description. We will see each one by one in detail. Go to slide number 6. So the part number describes the actual part of the component. So here in that example provided is a Generac PCB assembly board. This Generac is a company name. GENERAC is a Generac PCB assembly company name. So this PCB assembly is meant for a portable generator. If you see the top right corner, there is a name. That name is the part number. Okay, here in the below, the part number is mentioned clearly. The part number for this PCB board is OG58840SRV. And here the dimensions and the weight as well as the description for that PCB is mentioned. How this part number is numbered, we'll see in the next slide. So go to the next slide, slide number 7. We are having a part numbering system for mentioning the part number. Here GM A20000 is considered. This is nothing but a capacitor. This capacitor is mica dielectric compression trimmer capacitor. Mica dielectric means this capacitor is made up of mica dielectric material. Here this GM, this part number is splitted into different parts to specify the properties of the part. So here the part which is considered is capacitor. To specify the properties of the capacitor, the part number is splitted. So first if we consider GM. GM is the manufacturing material of the capacitor. Here the capacitor is manufactured by mica dielectric material. And next the letter A. The letter A represents mounting style. Mounting style means the capacitor can be mounted in several formats. For example, this A represents bracket mount for wired assembly. That is how this capacitor will be mounted on the PCB board. If we are considering surface mount technology, we'll be using a bracket mount for wired assembly. If it is mentioned as B means It is a printed circuit mount top adjuster. It has 4 terminals. So like this, for varying letters in the part number, we'll be having different mounting styles. The next number, here we are having 2. This 2 represents the size, that is the dimension of the capacitor. Here, this 2 represents the size as 0.375 cross 0.531 in inches, and within the bracket the dimension represents in millimeters, it is 9.53 cross 13.5. This represents in meters. Here this capacitor will be in rectangular shape, so its length and breadth are provided. 0.375 is the length and 0.531 is the breadth. And next, 00 is the code. Code means this may vary from 0000 to 03 and so on. By varying this code, we can have different capacitor model. Likewise, we are varying the resistor color coding. We can vary this code and have different capacitors. The last 2 digit 00, and the last 2 digit represents the modification. If there is any modification, here it is 00. So there is a no modification. It is a standard capacitor. If it is 1 means it has mica insulated screw. If it is 02 means it has ceramic insulated screw. Like this, we'll be having some modification in the general standard capacitor. Thus the part number describes the properties of the part. That is, here we have taken the capacitor. Likewise, in the previous example, slide number 6, this represents the part number OG58840 SRB represent the properties of the PCB assembly board given. Next we'll see component name. Go to slide number 8. We are having several electronic components. So each and every electronic components have its unique name. In the PCB designing tool, we'll be representing each and every component by a unique name. You might have seen it in the PSpice tool itself. For choosing the power supplies and for choosing resistor, capacitor, we'll be choosing different names available in the libraries. Likewise, here we are having several capacitors, diodes, ICs, transistors and LEDs. All these will be represented by its component name. Go to the next slide. This slide number 9. Here, different component names of microphones is given. That is, for the mobile phones, we are using different types of microphones. Based upon the cost and quality of the microphone, the price of the mobile will be decided. For high cost mobile phones, we'll be using high quality and high cost microphones. So there are different types of microphones are provided. Here there are 2 types of microphone. One is MEMS microphone, the one which is shaped in a rectangle, that is similar to the mics represented by the number 2, 3, 4, 5 and all, or MEMS microphone, that is it is a mic that is etched in a silicon wafer using MEMS technology. A rectangular shaped wafer or a chip is done by using silicon wafer using MEMS technology. MEMS technology means it is a micro electrical mechanical system technology. And other mics, which is cylindrical in shape, is a electrolyte microphone. It is a type of condenser microphone. It is a permanently polarized capsule. And these microphones can be given a component name as SH001, SH002, SH033, SH028. Likewise, each and every type of microphone has its own unique name. Next, go to the slide number 10. The figure in the slide number 10 represents the PCB board. All those marking represent several components. If we consider the ICs that is given in the right hand side, there are two ICs on the board and several resistors. All those resistors are marked by blue lines and transistors and inseparable assembly. So what do you mean by inseparable assembly? Inseparable assembly means it is a piece part which is fabricated. You can see the inseparable assembly represented by the violet lines. It is a two blue color box, rectangular box placed on the PCB board. It is a fabricated part for a specific functionality. Next is terminal board. Terminal board is a insulating material which provides electrical terminal. Here this terminal board on the PCB board represent two black color boards. One is black color and another one is in ash color board, and these two terminal boards provide terminus for electrical connection. And there are several resistors and several diodes and capacitors. So there are numerous diodes, capacitor, transistors to have a unique name for each and every diode, capacitor, resistor. We are giving reference designator. For resistor, like we saw in the previous case, R1, R2, like that we'll be giving reference designator. For transistor, we'll be giving as T1, T2, likewise. It is our wish we can give any name for as reference designator, but it should be a unique name given for that component. Next, go to the slide number 11. The slide number 11 represents the package name. Here, in the left hand side figure, to see it, the package for the IC given is LM386. LM386 is a low power audio amplifier IC. LM386 is a low power audio amplifier IC. It is a 8-pin IC and it is packaged in DIP08. I hope you all have studied. DIP means dual inline package. It is the type of IC packaging. This package will be similar to your AND, OR and XOR IC gates which you have studied in digital electronics. Like this, we'll be having LM386, but it is a 8-pin IC. So the type of package is specified by the package name. And the right hand side image shows the choosing of package for an IC 4093. That IC is mentioned in the title bar of the dialog box provided in the right side image. This 4093 IC is a Smith trigger IC. And this Smith trigger IC includes 4 Smith trigger circuits. Here, in the left image, Smith trigger IC, we can see several package materials. In that, here the chosen material is MCI. So, the description for the material is also provided. The description for the package MC14093B PSS OP14 is also provided here. It is a plastic thin shrink outline. That is, the package is made up of thin plastic package, and it is a 14-pin IC. So it is mentioned as 14 leads. There's a body width is 4.4 mm. The dimension is also given here. Likewise, in the PCB designing tool, after choosing the ICs or after choosing a component, You can choose the components package. That components package is specified by means of package name. Next, go to slide number 12. Next, we'll see value. Value means, for example, if we consider resistor means, what is the value of resistor? We'll say it as 1 kilo ohm resistor or 10 kilo ohm resistor likewise. The capacitor also you will specify it by means of 10 picofarad or 10 microfarad likewise. Likewise, here in the example provided in the slide number 12, it is a double layered PCB board. The board is named as RO4003C. It is used for high frequency and low cost applications. The table provided in the right side shows the property, because by using the value we can say the property. For example, if you are saying the resistor is 1 kilo ohm or 10 kilo ohm, that specify the property of that component. Likewise, this value represents the property of this board. The PCB board property means it represents the dielectric constant. For each value of the PCB board, we'll be having different dielectric constant. Here in the table provided in the right side, there is a table provided in the top shows the dielectric constant of two types of values of a double-sided PCB. There is RO4003C as well as for RO4350B. Here we are having two different types of dielectric constant for two typical values of PCB board. Here, process specification and design specification values is given. Design specification means before designing the board, you will be keeping a specification that the dielectric constant value should be 3.55 or 3.66. After designing the board and after it is subjected to processing, that is a assembling or not, or like that, the dielectric constant may vary, and that is provided in the top value 3.38 and plus or minus 0.05 is the tolerance. So dielectric tolerance value provided. The below table shows the frequency and skin depth. We have already said this PCB is meant for high frequency and low cost application. For different frequencies, what are the values of skin depth? That is a copper depth to be coated over the board is provided. The skin depth is provided in terms of millimeter as well as in micrometer. Next we'll see manufacturer. Go to slide number 13. For example, if we see a processor means the manufacturer of the processor can be several companies. For example, the microprocessor board can be manufactured by Intel or ARM processor or Toshiba. Like that, we are having several manufacturing companies. Here, in the slide number here, in the slide number 13 shows manufacturer of PCB boards. So this PCB way, ATEC circuits, high-tech, agile circuit, all PCB, all those represent the PCB manufacturing and designing companies. So like this, we can specify manufacturers for all the components so that it will be easy for buying those components and designing it in real world environment. All these symbol, schematic diagram and PCB layout can be done in PCB designing tool like CAD or ECEDA. After that, after verifying the PCB board, we'll be making it into a real PCB board in real world. For that, you can specify the manufacturer of the component because some PCB boards may vary depending upon the manufacturer. So, specifying the manufacturer is also an important thing. Next, we'll see description of the components. Description of the components means, for example, if you are building a circuit, the purpose of the circuit should be said. What is the purpose of the circuit? In the previous example, we have seen a stable multivibrator. So what is a stable multivibrator? It is used for generating continuous pulses. So that description should be provided along with that component. As same here in the 14th slide, the description is provided. That is, this PCB board is meant for Canon EOS 70D camera assembly. This is a camera assembly board. And next, so till now we have seen symbol properties. So what are the symbol properties we have seen till now are, first we saw what is meant by part number, then component name, reference designator, package name, value, manufacturer and description. Next we'll see schematic diagram. So you all know what do you mean by schematic diagram. Schematic diagram is a circuit diagram which represents all the electrical components and its connection. So go to slide number 15. This is an example schematic diagram. In the schematic diagram, what are the components available? Here we are having a PIC microcontroller IC. In center you are having an IC, just PIC microcontroller IC, and then at the top you are having a switch. That switch is start switch, and then at the bottom that circle represents 3-volt battery. It is a 3-volt button battery, and then the right sides you are having LEDs and resistor. So in schematic diagram, there are 3 stages. First, we have to generate the symbols. Symbols means here the IC, there is PIC microcontroller IC, start switch, 3-volt battery, LED and the resistor which are used as symbols. We have to generate it. That is, we have to fetch all those symbols from the library. And next step is placing the symbols. Placing the symbols means we have to place all those symbols in the schematic diagram. Why this placing is important means because you are going to convert this schematic diagram into PCB layout on a PCB board. So that placing of different components is considered as important because the spacing analysis of the placing is very tedious here. And the last stage in schematic diagram is connecting symbols. So the first one, we have to generate the symbols. The next stage, we will be placing the symbols, and next will be connecting all those symbols. Here, using the microcontroller and a battery, a start switch is also provided here. And when the switch is on, the battery supplies power to the microcontroller and the LEDs will be glowing. For that, the schematic diagram is given here. That is to glow the LED using PIC microcontroller by means of the switch is provided in this schematic diagram. Next we will see netlist generation. Once a schematic diagram is drawn, then netlist is generated. Netlist. Netlist means it is a text document. It contains the ASCII characters. ASCII characters means it includes alphabets, numerical values, symbols and all. So this ASCII text is a netlist. So from the schematic diagram, we will be generate a netlist file. My audio is muted in between. Whether you all can hear it or not. நீங்க எது வரைக்குமா கேட்டிருக்கீங்க இது வரைக்கும் நான் பார்த்ததுல? Okay, I will continue. Slide number 19 shows the netlist information. Here it shows the processing time. The processing time is given in millisecond. And next below, there is a DEF. This DEF is a definition for the nets created. This definition for the connection created in the circuit provided in the slide number 15. Okay, audio வந்து 16 ஸ்லைட்ல இருந்து மியூட் ஆயிட்டுன்னு சொன்னீங்களா? அதனால 16 ஸ்லைட்ல இருந்து நான் மறுபடியும் ரிப்பீட் பண்றேன். So go to slide number 16. Slide number 16 we will see netlist generation. So what do you mean by netlist means? It is a text. It is a text document which contains ASCII characters. ASCII characters means it contains alphabet characters and numerical characters and some symbols. These are netlist, and this netlist contains information about connection of electrical components. That is how different electrical components, the resistor, capacitor, or some ICs, or switches, or batteries connected in the circuit diagram. All those connections are represented in a textual format in netlist. This netlist is used for generating, routing, or interconnections on the board by the layout tool. If you are using a layout tool, you need this netlist for providing the routing connections on the board. Then we'll see the parameters of netlist. So what the netlist comprises of? Netlist comprises of a header. Header means this header includes the name of the design. What is the design is for? Then we'll be having the time and date at which a netlist is generated. Then it includes some statistical information like total number of nets. Nets means interconnections. So what are the interconnections available in the circuit or the schematic diagram will be provided in the netlist. Then the processing time. Processing time means the time for generating the netlist from the schematic diagram. This processing time will be usually in milliseconds. The slide number 18 shows an example of a schematic diagram. It shows a 3-layer schematic diagram for a 3-layer PCB board. See, in the schematic diagram, left side we are having a layer 1, and in right side we are having a layer 2, and bottom we are having a layer 3. So likewise, in a single schematic diagram, we can have multi-layer PCB board designing, and this schematic diagram will be converted into netlist, and from the netlist PCB layout will be designed and it will be transferred to the PCB board. Go to slide number 19. The slide number 19 shows an example of netlist information. The netlist has a header. That header includes the name of the netlist. Next, we are having the date and time at which the netlist is generated. Next, we are having the processing time. 6.4 is the is given in milliseconds. That is for converting schematic diagram into netlist. The time consumed is 6.4 millisecond. Then here at the below we are having DEF 0, DEF1, DEF2 and so on. All those are the definitions for the nets we have created. Nets means the connections we have created. This netlist information is provided for the slide number 16 schematic diagram. In the slide number 15, we are having different diodes, resistors, microcontroller and switches. The connections between them are represented here. Here, for example, if you take DF1 in slide number 19, go to slide number 19. The line DEF, the definition for first netlist is D2 1, R2 2Z. The D2 1 represents the pin number 1 of diode 2 is connected with pin number 2 of R2. That R2 2 represents pin number 2 of R2. So the connection is done between pin number 1 of D2 and pin number 2 of resistor. This you can check in the slide number 15. So if you check the slide number 15, there are several diodes. In the diode 2, the pin number 1 is connected to the resistor 2 by means of second pin of the resistor. Likewise, each and every connection is presented in the textual manner in the netlist created. So that DEF0 is definition 0 to definition 17 represents the nets which are created. There is a connection which are created. This definition doesn't have any name, so only we have given any name. There is a DF0, 1, DF2, DF3 like that. But in that circuit diagram, we have some nets which are named, that is BCC and ground. BCC means the supply. All those supply are given to BCC connection and the terminals which are to be grounded is provided in the ground netlist. Here in BCC U1, this U1 represent the PIC microcontroller available in the slide number 15. So the pin number U15, the pin number 5 of microcontroller is grounded, and then D12. D12 means there is a diode 1, pin number 2 is grounded. Likewise, there are several pins provided which are to be grounded. The same way VCC. VCC if you see means U114. The pin number 14 of a PIC microcontroller is given to supply VCC. Then R91, that is in the resistor number 9, the pin number 1 is given to supply. Like this up to R10 1, there is a resistor 10, first pin is given to supply. In that we are having some letters also, that is Z, U, O, I, B like that. All those letters represents the direction of the pin. For example, B represents the pin is bidirection. O represents the pin is output pin. I represent this is a input pin, and U represent It is a unidirectional pin. Unidirectional means the pin can transmit signal in one direction only. B means it is a bidirectional pin. That is, it can transmit signal in two direction. Z represent that the type of pin is not defined in the schematic diagram. So all these alphabet represent the direction of the pin. So if you take VCC U114, U114 means it represents pin number 14 of microcontroller. Then R9 1Z. R9 means it's a resistor 9 and 1Z means the first pin of resistor 9. Z represent that pin is undefined. Next, B11U. This B1 represents the battery available in the schematic diagram provided in the circuit diagram in slide number 15. So B11U means the battery 1, the pin number 1 is unidirectional. That is, it transmits signal in one direction only. Likewise, the letters represents the bidirectional or unidirectional or input output pins. We will end today's session. If you have any doubt or you didn't hear any content while I am telling, you can ask me.